Good evening, and welcome to the first Sky at Night of 1982. I'm glad to say that our newsletter, number 4, is now ready, and if you want it, all you have to do is to send in a stamped, addressed envelope, marked Newsletter in the top left-hand corner, and sent to the usual address. Newsletter number 4, The Sky at Night, BBC Television, London, W12 8QT. And I would be very grateful if you wouldn't put personal letters in with these requests, because those are the ones that are apt to go astray. I do, in fact, answer every letter that I get, but I'm afraid for various reasons I have got rather a backlog at the moment. I am working through them as quickly as I can, so if you've written to me and you haven't heard yet, please bear with me. I promise I'll answer you as soon as humanly possible. One thing I've mentioned in the newsletter, which won't happen in 1982, is the famous planetary alignment. Now, this Jupiter effect, as it was called, began with a book published some years ago by Gribbin and Pargman, in which they maintained that in 1982, all the planets would line up on the same side of the Sun, and their combined gravitational pulls would affect the Sun, that would affect the Earth, and the results would be dire, including the possibility of serious earthquakes. Well, that book caused a great deal of interest, but I can assure you it's absolutely unfounded. For one reason, the planets will not, in fact, line up in 1982. The actual alignment is rather like this, and you can see that Jupiter, Saturn, Uranus and Neptune are rather in a curve, and that was rather useful to the space planners, but they certainly aren't pulling in the same direction, and Pluto is nowhere near. Well, that's one point. Secondly, quite apart from the fact that there is no alignment, it takes only very simple mathematics to work out that even if all the planets were pulling in the same direction, it couldn't possibly affect anybody or anything. So let's hope we've now heard the last of the Jupiter effect, which is entirely non-existent. Much the most interesting event of this month has been the total lunar eclipse of January the 9th. And this was visible in the evening, and some people at least had a good view of it. I think most people know how a lunar eclipse occurs. The Earth goes round the Sun, and the Moon goes round the Earth. So there must be times when the Earth, the Moon and the Sun are lined up with the Earth in the middle. And when that happens, we have a lunar eclipse when the Moon goes into the Earth's shadow. Let me show you what I mean by means of a demonstration. Here we have a lamp to represent the Sun. That's on the lower right-hand side of the screen. There is the Earth, and slightly over to the right of the Earth, we see the Moon. Do bear in mind that this is not to scale. The Sun is big enough to swallow up 1,000,000 globes of volume of the Earth, and the Sun is 400 times as far away as the Moon. But it will certainly suffice to show what happens. So there is the sunlight coming from the lower right-hand part of the screen, shining upon the Earth. Now, as the Moon moves round the Earth, it may pass into the cone of shadow cast by the Earth. Its supply of direct sunlight is cut off, and it shines entirely by sunlight, and therefore it turns a dim, almost coppery colour before it moves out of the shadow again, which may take well over an hour. The Moon doesn't normally disappear completely because the Earth has an atmosphere. And round the Earth's surface there is a shell of air, and that bends or refracts some rays of light onto the Moon's surface. So generally you can see the Moon even at mid-totality. If the Earth had no atmosphere at all, then of course the Moon would disappear completely. We don't get lunar eclipses every month because the Moon's orbit is tilted compared with ours, and generally it passes above or below the cone of shadow. But we did have a total eclipse on the evening of Saturday, January the 9th. And it was a good one. Totality lasted for over an hour. Well, what we'd planned to do was to have cameras and equipment here on the roof of Television Centre and record the eclipse. And I needn't tell you what happened, because we were in the midst of that very bad spell of weather, and all we saw, I'm afraid, were clouds with intermittent snow. But we also had cameras at the studio in Birmingham, and they did have a very good view of the eclipse. And they sent back excellent pictures, which I actually watched as they came through. And it was fascinating to do so, because I, for one, had never watched the progress of a lunar eclipse on television before, and I'm not sure that anybody else has, and the pictures were remarkably clear. The eclipse began just after 6:30, and you could see the Earth's shadows starting to encroach upon the Moon and dim it. And as time went by, that shadow grew and grew, until, by 7 o'clock, a large part of the Moon was covered. Now, eclipses can be of various kinds, either bright or dark. Sometimes the eclipse moon is so bright it's difficult to believe an eclipse is going on. At others, it can vanish almost completely. This was a mixture. It was a dark-ish eclipse, but the dark part of the Moon could just about be seen. And slowly the shadow crept across. The bright crater Tycho was covered. And then, as totality neared, you could see very plainly that the curve of the shadow was not concentric with the Moon's limb. And that, of course, is an age-old proof that the Earth is curved and is larger than the Moon. And slowly the shadow crept across until, at 7:17, the eclipse was total. Now, that is a view of totality. You may find it rather hard to see on your screen. Of course, it was easier to see with the naked eye, and from Birmingham it could be seen quite clearly as a sort of orange disk. I'm afraid the orange colour was too faint to come out upon the screen, but it was there. But it was definitely a darkish eclipse. You could see a certain amount of detail on the eclipse part, but it was not easy. This is a photograph of mid-totality. The film has started again, and there the moon is right in the middle of the Earth's shadow, by no means easy to see. And then finally, the eclipse neared its end, and at 8:35, the Earth's shadow started to draw off the moon. And again we see a bright part of the lunar surface appearing, and that brightness increases until very slowly the moon becomes first a crescent, then a half, and finally returns to normal, and the eclipse is over. Of course, had you been on the moon and able to feel temperatures, you'd have noted a very sudden drop, because when the sunlight is cut off from the moon, the temperature goes down very sharply indeed. The moon has no atmosphere to blanket in the sun's heat, and the temperature can go down by 100 degrees in an hour, recovering also quite rapidly. Well, I think you'll agree that was well worth watching. And without claiming for one moment that lunar eclipses are as important as eclipses of the sun, they're spectacular, and this was the best total eclipse that we're going to have for some time, unfortunately. Well, I saw nothing of it at all except on television, but I very much hope that you did, and it will be some time before you have another chance. In fact, there's going to be an eclipse of the sun on January the 25th, but we're not going to see that from here. And in any case, eclipses of the sun are quite different from those of the moon, and they're produced by the moon going in front of the sun, as seen from the Earth, and actually blocking it out. So there's no shadow concerned here, it's actually the body of the moon. This was a photograph of a partial eclipse of the moon that I took some years ago, way back in 1973. And the sun there looks like a crescent. Of course, the dark part is being covered up by the moon. And here's a rather interesting picture, taken a long time ago now. Over on the left-hand side, where it's all black, that is, in fact, the body of the moon. And you can see that it's considerably darker than the sunspots that you can see over to the right. And that is because the sunspots, those patches on the sun, are not genuinely dark at all. Their temperature is about 2,000 degrees lower than that of the bright gaseous surface or photosphere, so they normally appear dark. But when you see them compared with the genuinely dark disk of the moon, you can realize they're not so black after all. But the most amazing spectacle is a total eclipse of the sun, when the moon passes completely in front of the bright disk, cuts it out, and then for a few minutes, never as long as 8 at any one eclipse, we see the sun's atmosphere, the chromosphere, the so-called red flames or prominences, which are glowing hydrogen, and the outer corona. And believe me, that is really worth seeing. But unfortunately, the moon's shadow is only just long enough to touch the Earth, and from any one position on the Earth, total eclipses are by no means common. The last one visible from any part of England was way back in 1927, and the next one won't be until August the 11th, 1999, when you will have to go to Cornwall. But I hope it's clear on that day, and if I'm still around, we shall most certainly be doing a broadcast of it. So much then for eclipses. What about the night sky? And beginning, as usual, with planets, not really a very good time, because the only planet in the evening sky now is Venus. And when I drew it a few evenings ago, it appeared as a crescent, and it's a narrower crescent now. And it's going to go on becoming narrower and narrower until for a week or so at the end of January, we're going to lose it completely as it goes more or less in front of the sun. And then in February, it will reappear in the eastern sky before dawn and remain prominent for, well, all through February and March. The other bright planets, Mars, Jupiter and Saturn, are all together in the general area of the constellation of Virgo. And here we have them. You can see Ursa Major, the Great Bear, Arcturus and Virgo with Jupiter, Saturn and Mars, all round about there. But of course, those are not up at the present moment. These at the moment are morning objects, and they don't rise until well after midnight. And so I'll have a great deal more to say about them later, when all those planets are going to be better placed in the sky. So let's turn now to the actual stars, and we begin, as we so often do, with Ursa Major, the Great Bear, showing the way to Polaris, the pole star. And bear in mind that Ursa Major is always visible whenever the sky is sufficiently clear and dark, because it's so near the pole that over Britain it never sets. And its stars are reasonably bright, but we have to admit, I think, that Orion is the constellation which dominates the winter sky. And there it is in the evenings now, in the south, and you can't really mistake it. It's got that characteristic shape, and it's two very bright stars, the orange-red Betelgeuse in the upper left of the constellation, and the brilliant white Rigel in the lower right. And Rigel really is a cosmic searchlight, something like 60,000 times as bright as the sun. And using Orion, we can find other members of its retinue. There is, for example, Sirius, the brightest star in the sky, and the Great Dog. And I've had quite a number of letters from people who say, what's that very bright thing low down in the south, flashing various colors? And that is, of course, Sirius. And like all stars, it twinkles, not because of it itself, but because of the effects of the Earth's unsteady atmosphere, which makes a star flash. But Sirius is so bright and rather low from here that it shows the twinkling very obviously, even though really it's a pure white star. Then we also have the twins, Castor and Pollux. Almost overhead in winter evenings, we have Capella in Auriga, the charioteer, a lovely yellow star. And upwards, the stars of the belt lead to Aldebaran in Taurus, the bull. But Orion itself is so prominent that it's rather entertaining to photograph it. And I've got a couple of rather unusual photographs here, which I think you may like to see. First of all, here is one showing the stars of Orion drawn out into short strips. And the reason for that is that it was taken with an unguided camera. The stars, of course, appear to shift across the sky from east to west, and so with a time exposure, they get drawn out into trails. And it's rather entertaining to do that. All you need is a fast film and an ordinary fixed camera, and leave the shutter open for 10, 20 minutes, something like that, and that's the kind of picture you will get. And below the three stars of the belt, you can see those three stars in a line, making up the hunter's sword, where we have the magnificent nebula I'll talk about in a few minutes. And here's another picture of Orion, a much older one actually, and you will see something strange about that. There are the stars of the belt, there's the nebula, there to the lower right is Rigel, but where is Betelgeuse? And if you look there to the top left, you will see it, but not very well. And the reason is not far to seek. That was a blue-sensitive film, and Betelgeuse is a red star. And so on that particular film, Betelgeuse doesn't show up at all well. Take the picture with an ordinary film, and Betelgeuse will appear as the brightest star in the constellation, apart from Rigel. Now let me come on to something else which is well placed at the moment, again in Taurus. We begin with Orion, we go through Aldebaran, and we come on with a kinked line to the lovely open cluster of the Pleiades, or Seven Sisters. And I think this is rather a good time to say things about open clusters in general, because several of them are on view. The Pleiades is the best example in the sky. It's known very often as the Seven Sisters. When you look at it first, it appears as a kind of a smudge, but then when you look more closely, you can see there really are individual stars there. And some years ago, it must be a long time ago now, in the early 1960s, I think, we carried out an experiment in the Sky at Night program to see how many stars in the Pleiades could be seen by people with average eyesight on a clear night. And the answer came out at 7, although some people could see more, and I have got one friend who can see 15 or 16. But if you photograph the Pleiades with a large aperture, then of course you see many more than that. And there's a much more detailed picture of the Pleiades cluster. Many more stars are shown, and you can also see patches of nebulosity. And that is because there's gas and dust spread between the individual stars. All the stars in the Pleiades have got their own names, as the brighter ones have. The leader is Alcyone, there in the middle, magnitude 3, quite a fairly prominent star. And look over to the left-hand side, you'll see two of the Pleiades close together, Atlas and Pleione. And Pleione is rather interesting because we know that it's what's called a shell star. It's unstable, it's probably egg-shaped, and periodically it throws off shells of material, although of course we can't see them directly, and we have to study them with rather indirect means. And also Pleione is slightly variable. But most of those stars, if not all, can be seen on a clear night by anyone with good eyes, and certainly all of them can be well seen with binoculars. But I'm afraid you won't see the nebulosity spread between them, because it isn't bright enough. If you want to see a gaseous nebula, where to look but Orion, the lovely nebula in the sword, and that you can't mistake. Now, in that picture, we can see the stars of the belt near the top, and below the sword, and right in the middle of the sword is that fuzzy patch, which is the great nebula Messier 42. And when that's photographed with a large telescope, it is a superb sight, as we can see in that picture. But do bear in mind that although the colors are absolutely genuine, they really are there, if you look at the nebula direct through a telescope, I'm afraid you won't see them because the light level is too low. But it is a particularly good example, and the nebulosity is shining partly because it's being lit up by the very hot stars inside it, and partly because those stars are so hot that they're making the nebula shine to a certain extent on its own account. So that's called an emission nebula. Now, the nebulosity in the Pleiades is not the same kind. The stars in the Pleiades are hot, but they are not so hot as that. And so we have here a nebula which is simply being lit up by the stars inside it, and that's called a reflection nebula. Now, the Pleiades is a good example of a fairly close-knit galactic or loose cluster. But there are plenty of others, not all of them as closely knit as the Pleiades. And there's one very good example, again in Taurus, and this time round the bright orange star Aldebaran. And if you look carefully with the naked eye, you will see extending over to the right-hand side a kind of little V of stars. And these make up the Hyades. And when you look at them with binoculars, you see many more stars than that. And there's Aldebaran, slightly to the left of the center, obviously the brightest star in that picture. But the Hyades are not nearly so condensed as the Pleiades. And loose clusters are not probably permanent members of the galaxy, because we believe that the stars in any particular cluster are created at the same time out of the same cloud of nebular material, and then you have your individual stars. But of course they're being perturbed by non-cluster stars outside, and they're gravitationally not closely linked, and over the passage of time, loose clusters get broken up and lose their separate identity. And the Hyades, of course, are more scattered than the Pleiades. But there's another point also. The Hyades are rather overpowered by Aldebaran, and yet Aldebaran is not a genuine cluster member at all. It simply happened to lie almost halfway between the Hyades and ourselves. Let me show you what I mean by a model. And there, first of all, we have the characteristic Hyades shape, with Aldebaran clearly the brightest star, and the V shape. But as you can see, it is a model. And now let's look at that from another angle. And this time you'll see quite clearly what I mean, because Aldebaran and the Hyades are not at the same distance from us, and we are dealing with a mere line of sight effect. There are various other open clusters visible now, too. There's one in Gemini, the twins. You can find Gemini easily enough from Orion. Castor and Pollux mark it out. And there is Messier 35, a nice open cluster, just visible with the naked eye and easily with binoculars. But not, I think, so spectacular as the sword handle in Perseus, which we can find from, as always, the Great Bear Ursa Major. We can also, by the way, find Capella, that lovely yellow star, almost overhead in winter evenings. But let's begin with Mizar, the double star on the Great Bear's tail, take a line through the pole star, come to Cassiopeia, the double, and then use Cassiopeia to find the sword handle, which again is just about visible with the naked eye. But when you look at it through binoculars or a telescope, this is what you see. A lovely pair of clusters in the same low-power field, each about 70 light-years in diameter and something like 7,000 light-years away from the Earth. So they really do make up a magnificent pair. Of course, to see it properly, you do need optical aid. And people have been writing and saying, well, I would like a telescope, but I can't afford one. And it's quite true that a really good astronomical telescope does cost well over the £100 mark now. But why not use binoculars? These are 7 by 50s, a magnification of 7, each lens 50 millimeters in diameter. And using these, you can have good views of all those objects I've been talking about tonight. The Orion Nebula, the Pleiades, the Hyades, M35, and the sword handle. And you might even see the phase of Venus, although do remember never to look until the sun has gone safely down below the horizon. Binoculars are not to be despised, and if you haven't got a telescope, I do suggest that you think very seriously about them. There'll be plenty to see. Well, that, I think, is about it for this month. Only before I go, you might like to have one more very speeded-up view of that spectacular lunar eclipse. Good night.